So the first half of the unit is all about perfect competition. All right. The second half of the unit is going to be about monopoly. So in a perfectly competitive market, you have a bunch of different buyers and sellers competing against each other for the product. But in a monopoly market, the prefix mono means one. So monopoly is a single seller. So what I have here is I've set up sort of a scenario with this kind of situation going on. All right. So imagine I'm selling a good. Imagine I'm selling I don't know, maybe I'm selling notebooks. All right, so I'm selling a notebook, and I take a survey and I ask a bunch of people what they're willing to pay to get this notebook, and this is what my survey tells me. Okay, so Josh is willing to pay $1 for it, Lisa's willing to pay $7, Anna's willing to pay $5, Emma for a hoodie $8, and so on. Okay, so each one of those prices represents a different potential customer's willingness to pay for the notebook. All right. So if I offer this product for sale at a price of $9, well, there's only one person on this in this data set, right, who's willing to pay $9 for the notebook, and that's Mason. So if I offer it for sale for a quantity or for a price of 1, I'm only going to sell, or a price of 9, I'm only going to sell a quantity of 1. All right. So let's say I decide to lower my price. Okay, and if I want to try to sell more, okay, think about this. If I'm the only seller of a good, right? If I'm the only seller of a good, I'm the only option available for you to buy from, then the only reason why you wouldn't buy it from me is if the price is too high, right? So if I want to sell more notebooks, the only way I can sell more notebooks is I'm going to have to offer a lower price because there's only one person in this data set who's willing to pay $9. So if I want to sell more notebooks, right, I'm going to have to lower my price. So let's say I offer a price of $8, okay? Well, if I offer notebooks for sale for $8, there's two different people who are willing to pay $8 or more, right? Mason's willing to pay 9, Hoodie's willing to pay 8. So if I offer a price of 8, I'll sell 2 notebooks. So I'll sell one to Mason and I'll sell one to Hoodie because Mason's willing to pay 9. If I sell it for 8, he'll definitely buy it, right? If I want to sell more, lower my price to 7, well, now I have 3 people that are willing to pay at least 7, right? So if I sell it for 7, Lisa will buy it for 7. Mason will definitely buy it for 7 because he's willing to pay 9. Hoodie will buy it for 7 because he's willing to pay 8. So I'll sell 3 of them. If I lower the price to 6, I'll sell 4 of them. If I lower the price to 5, I'll sell 5 of them. If I lower the price to 4, I'll sell 6 of them. If I lower the price to 3, I'll sell 7 of them. 2, 8. And if I sell at a price of 1, all 9 people are willing to buy at a price of 1, so I'll sell 9 notebooks. Okay? So this is the data set that I have right now. Now, these two sets of numbers, price and quantity, this is what I could use to produce a demand curve, right? This would be our price, and this is our quantity. This is our y-axis and our x-axis. So these two sets of numbers right here, this will give me a demand curve for notebooks for me, okay? Now, total revenue, all right? Let's talk about total revenue and marginal revenue, all right? So total revenue is price times quantity, okay? So if I do price times quantity, right? 9 times 1 is 9. 8 times 2 is 16. 7 times 3 is 21. 24, 25, 24, 21, 16, and 9. Okay? This is my total revenue. All right? Now, first thing I want you to notice right off the bat, right? Total revenue, what does it do initially as price is falling? Well, as price is falling initially, total revenue is rising. Okay? And then it gets to the maximum. And then as price continues to fall, total revenue starts to fall as well. Now that's different than what we looked at with perfect competition, because in perfect competition, every time I sold a good, I sold at the exact same price. So every time I sold the good, my total revenue would increase by the same amount. So like if I wrote out the total revenue data for a perfectly competitive firm, the total revenue would continuously rise. That's not what it's doing here. It's rising and then it hits a maximum and then it decreases. Okay? That leads us to marginal revenue. Marginal revenue is your change in your total revenue when you sell one more. So each time I sell one more, okay, so it'd be my change in total revenue divided by a change in 1, right? So when I'm at 0 quantity, right, when I sell my first unit, my total revenue changes by 9. So my marginal revenue is 9. Then when I sell my second unit, my total revenue changes by 7. Then it changes by 5 and 3 and 1. And now it's -1, -3, -5, -7. Okay? So I want you to notice what marginal revenue is doing here too, right? In a perfectly competitive firm, this marginal revenue value should be constant and it should equal price. But you notice that that's not what happens here, right? Marginal revenue is declining here. Okay, so that's how, so marginal revenue's behavior is different for a monopoly than it is for a perfectly competitive firm. And there's a reason for this, and you need to know these reasons, okay? The reasons are, number one, again, I'm the only seller of this good. So the only reason why somebody wouldn't buy this good is because the price is too expensive, okay? So if I want to sell more, I have to lower my price in order to sell more. That's the first thing I need to know. The second thing I need to understand is this. When I lower my price to sell one more unit, I lower the price on all previous units sold. So what I'm saying is like, when I lower my price to $8 to sell to Hoodie, I'm also lowering the price that I sell to Mason to $8 as well. So I'm losing a little bit of revenue that I would have gotten from Mason, but I'm gaining all this revenue that I get when I sell to Hoodie, right? So that's the reason why our marginal revenue values are declining and they're less than these price values, okay? Now, I want to plot these values out on a graph, okay? So that's what I want to do next is I want to plot out my demand curve and my marginal revenue curve. Okay, so quantity and price, right? Now, if you look right here, right, this demand curve values, right, price goes down, quantity goes up. This is a regular demand curve. This is what we always have shown, right? It's a downward sloping demand curve is what we see. And so if I plotted this out, all right, I'm not going to plot out each exact number, but I just want you guys to kind of get an understanding of what's going on, right? I get a downward sloping demand curve, okay, because price is going down. Price is going down, this Y value is going down, and quantity is going up. This X value is going up, okay? If I plotted out marginal revenue for this company, okay, I want you to notice what happened here, right? It would start out the same place, but then it would cross the X-axis, right? It would become a negative value here. So what would happen is it would start here, and it would cross the X-axis and turn negative. This would be our marginal revenue, okay? Now, where it turns negative, where it crosses the x-axis, okay, it's always the same. It's always, if we have a linear demand curve, a straight line demand curve, then the marginal revenue curve will always cross the x-axis at the midpoint of the demand curve. So this right here happens at the midpoint of this demand curve, okay? That's what always happens when you have a linear demand curve and marginal revenue for monopoly. Now this demand, this is also our average revenue, and it's also our price, but it's not our marginal revenue. This is different than a perfectly competitive firm, right? A perfectly competitive firm would look like this. It'd be price and quantity. Okay, you can do dollar value, you can do price here, it doesn't matter. Okay, but a perfectly competitive firm, this would be marginal revenue, demand, average revenue, and price, right? So the marginal revenue, demand, average revenue, price curves would be constant, and all these values would equal each other. So it'd be one line, right? That's horizontal. That's not what's going on up here, right? Up here, demand, average revenue, and price equal each other, and they're decreasing. Okay, they do not equal marginal revenue, and marginal revenue, it crosses the x-axis at the midpoint of the demand curve. Okay, so that's the difference between a monopoly and a perfectly competitive firm. Now, when we did perfect competition, normally I would do side-by-side graphs, right? I draw the market over here and talk about how the market and the firm are interacting. I don't need to do that for this. And the reason why I don't need to do that for this is think about it. There's only one seller in this market. So for the firm is the market here. This is the market. So I don't have to do side-by-side graphs. The monopoly graph is the market graph, okay? All right, so the next question would be, all right, what price do we sell at and what quantity do we sell at? Well, it's the same rule as what we did down here. So down here, right, it's all based on where MR equals MC. So if I go down, this is going to be the quantity that's produced. If I go up, this is my price curve, so this would be the price that I sell at, right? But for here, it's the same rule, MR equals MC, okay, the profit maximizing. So I got to add in my marginal cost curve, okay? So that's my marginal cost curve, right? And it doesn't matter where that marginal cost curve crosses right here. That's not relevant, all right? But here's what I'm looking for, right? I'm looking for MR equals MC. So this curve and this curve, they both intersect at this point right here. So this is going to be the quantity that this company produces. That's going to be the firm's quantity. Okay, it's also the market quantity, so I can call this QF or QM or just Q, it doesn't matter. But that's going to be my quantity. The question is, where do I price it? Well, if down here, I go up from Q1 and hit the price curve. This is the price the firm sells at, right? This, I go up from Q1 and hit the price curve. This would be the price that they sell at. So if I go up from here, hit the curve, go across, this is going to be the price that the firm sells at. So I can call this QF or QM or Q1, doesn't matter. Okay, but notice what I'm doing here, right? I find my quantity first, where MR equals MC. That's the quantity this firm's going to produce. And then this firm says, okay, we're going to produce QF. Okay, well, what are people willing to pay to get QF? Well, the demand curve, the price curve, is what tells us what people are willing to pay. So we go up from QF, we hit the price curve, and we go across, and we see that this is the price that people are willing to pay to get this product. So that's the price that they're going to sell at. Okay, so that's how a monopoly firm determines what it's going to produce and how it's going to price. Now, is this firm making a profit or taking a loss? Well, we don't know that because we got to add in our average total cost curve in order to know that, right? That's what we have to see. Okay, now a monopoly can make a profit, they can take a loss, just like a perfectly competitive firm can. Okay, you can have a monopoly on a product, be the only seller of a bad product that nobody wants, right? Like if you're the only seller of it, you're a monopoly. Even if nobody wants it, you're the only seller, so you're still a monopoly. Okay, so don't assume that just because you're a monopoly that you're going to always make a profit. You may not, okay? Now I'm going to show you a firm that is making a profit on here, and so let's see how we figure that out, all right? So I'm going to say that they're making a profit, so what I need to make sure of is that ATC is less than demand, less than price, right, at quantity. So here's my ATC curve, and if I go up from quantity, I hit the ATC curve right here, okay? That would be my ATC right there, okay? My ATC is less than my price, so this firm is making a profit. Now, how much profit are they making? Well, if we go up from QF and hit the ATC curve, this blue box would be my total cost. If I go up from quantity and hit the price curve, price times quantity is total revenue, so this red box right here, this red box, that would be all my total revenue, this whole red box, all of this, all the way down. Okay, that would be my total revenue. Total revenue minus total cost equals total profit. So I'd be the red box minus the blue box would leave me with this green box right here. So this green box, all of that would be my profit for this firm. Okay. Other things I want you to think about, all right? We talked about allocative efficiency when we talked about perfectly competitive firms. Let's talk about whether or not this is allocatively efficient, okay? Well, allocative efficiency happens when price equals marginal cost. So if I look down here, okay, price equals my marginal cost, right? Price equals marginal cost, right? If I go up from quantity, I hit the marginal cost curve, I hit the price curve at the same time, my price equals my marginal cost. So this relationship, price equaling marginal cost, is true. So this firm is allocatively efficient. Okay, what about here? Well, if I go up from QF, okay, and I hit the price curve, right, my price is way up here. If I go up from QF, hit the marginal cost curve, my marginal cost is right here. So here, right, price is greater than marginal cost. Price, I said PC, that should be MC, my fault. It should be MC. Okay, price does not equal marginal cost. Instead, price is greater than marginal cost. So this market, this firm is not allocatively efficient here, okay? And if it's not allocatively efficient, that means that there's a deadweight loss somewhere. So where's the deadweight loss? Well, what is allocatively efficient? Well, what is allocatively efficient is where price equals marginal cost. Where does that happen? It happens right here. So where our marginal cost curve and our demand curve, our price curve, intersect each other, right? This quantity right here, this would be the socially optimal quantity, QSO. Okay, QF, that's what we get. QSO is what society wants. So the difference between those two is going to be where our deadweight loss is, right? So our deadweight loss would be this blue triangle right here. All of this would be the deadweight loss to society that happens as a result of this monopoly. Okay. The other thing is productive efficiency, right? If this firm is in long run equilibrium down here, okay, price equals minimum ATC. Notice, right, that does not happen here, okay? Again, right, price does not equal ATC. So it's neither productively nor allocatively efficient.